Dear student, our topic will be continuous. Today's our topic is supramolecular effect in photochemical hole burning. Here we are discussing on supramolecular devices. Dye molecule incorporated in crystalline or amorphous solid matrix are located in different environment and therefore present a distributions of absorption frequencies whose envelope results in a broad absorption band. When such dye-doped media are irradiated with laser light under condition where the guest species are frozen in their environment in very low temperature, given molecules are selectively affected so that very narrow and stable hole can be burned into the absorption band. Such photochemical hole burning in condensed material it's because of its very high resolution of great interest of high density optical storage. The effect between dopant and matrix are clearly of supramolecular nature, and each dye molecule with its surrounding matrix species may be considered to represent a supramolecule. Thus, hole burning is especially a supramolecule interaction photochemical process. As a consequence, the manipulation of intermolecular interaction and recognition process in the condensed phase would allow the designed generation of an range environment distribution as well as induce specific changes in the absorption feature of the dye molecules, thus taking into account explicitly the supramolecular effect often ways to control the environmental feature in hole burning experiments. A number of far-reaching applications have been envisaged from ultra-narrow optical fiber to high-density optical storage, holography and optical molecular computing. Optical data processing with bacteriophotism displays very interesting feature. Room temperature and single molecule hole burning represent exciting recent developments. The photochemical and photophysical process discussed above provide illustration and incentives for further studies of photo effect brought about by the formation of supramolecular species. Such investigations may lead to the development of photoactive molecule and supramolecular devices based on photo-induced energy migration, electron transfer, substrate release, or chemical transformation. Coupling to recognition process may also be transduction of molecular information into photo signals. The molecular design, selective intermolecular bonding, and supramolecular architecture with photophysical, photochemical, and optical properties are brought together, building up recognition dependent supramolecular photonics. This is the also device of the molecular supramolecular electronic devices. Electron conducting devices, molecular wire. This is the important topic, molecular wire device designed by the supramolecular devices. This is also device supramolecular devices. Among the various devices and components performing molecular scale electronic functions that may be imagined, a crucial one is molecular wire, which might cooperate as connector permitting electron flow to occur between different sorry between the different element of a molecule electronic system. There main three main classes of electron transfer process may be considered. Number one is the electron transport by redox active molecule acting as mobile carriage through membranes. This may or may not also involve electron transfer from one carrier to another during an encounter. Second is the electron hopping between suitable redox active group attached to the backbone or assembled by non-covalent interaction. Third is the electron conduction along a continuous conjugation path formed by a pi bond, which may also involve other electron transmitting groups such as strand, sigma bond, etc. It represents an electron channel and embodies specifically the radius of a molecular wire. The components affecting these processes may be either organic or inorganic. The two extreme cases, one is the carrier mediated and second is the channel mediated electron transfer, represent in shown in below figure. The first is coupled to the flow or counterflow of a positively or negatively charged species respectively. It has been considered in section 6.4. Numerous studies on electron transfer across vesicle bilayer membrane have been performed employing a variety of factors, especially in view of the relation to biological electron transfer. The design of a molecule wire should satisfy three criteria. One is the contain an electron conducting chain. Second is the possess terminal electron active and polar groups for reversible electron exchange. And third is the be long enough to span a typical molecular supporting element such as the monolayer or bilayer membrane. Our approaches towards the design of molecule wire was based on the Caro-Wallgens CV2 plus Caro-Wallgens long conjugated polyolefinic chains being pyridinium groups at each end, which combine the structural feature of carotenoids with the redox properties of methyl viologens. Such components were shown in figure number 98 were synthesized and shown to be incorporated in a transmembrane fashion into bilayer vesicle, as is also the case for other carotenoids bearing terminal hydrophilic groups. The orientation of carboviologens in model lipid membrane was studied by linear dichroism measurement. Dichroic ratio were determined on carboviologens of different lengths, solubilized in littropic lamellar phase of different thickness and macroscopically aligned between quartz plates. The orientation parameters obtained indicated transmembrane arrangement for carboviologens of length compatible with the bilayer thickness of the membrane. Electron transfer experiment employing the CV2 plus dihexadecyl phosphate vesicle system did not give positive result, perhaps because of the high negative change of the membrane surface, which may modify the redox potential of incorporated CV plus 2 and reduce interfacial electron transfer rates. However, an incorporation of Jupiter ionic carboviologens CV2 plus such as compounds in 99 into phospholipid vesicle, electron transfer occurred between an external reducing phase and an internal oxidizing phase using only a small amount of incorporated and acceleration factors of 4 to 8 hour background was obtained. This clearly indicated that Cv2 plus did induced electron conduction plus radiolysis studies provided information about the reduced Cv plus and neutral Cv species that are expected to the intermediates in the process. Here these are the types. Now we discuss polarized molecular wires rectifying devices. Conjugated polyolefinic chain bearing an electron acceptor group one on one end and a donor on the other represented polarized molecule wire that should display preferential one-way electron transfer and could act as rectifying components. Such molecules, donor acceptor carotenoids (DE carotenoids), were prepared and shown to possess very pronounced non-linear optical properties in powder form in solution or in Langmuir blockade film. Oriented incorporation into organized assemblies and electron transfer experiments might reveal one-way conduction by polarized molecule of this similar type. Approaches to organic rectifiers have been made using donor sigma bond acceptor species containing a donor and a acceptor group linked by an introducing covalent sigma bridge, a system based on a conjugated d pi. Here is pi bond between donor and acceptor unit. Incorporated molecular layer has been responded, as well as a bilayer rectifier at clay modified electrodes. Theoretical analysis of electron transfer through such a single chain molecular wire have been given. Species of this type may contribute to the development of molecular transistor. Dear students, please prepare your notes by the help of the PDF and learn also, because this year is the final year of your M.Sc, and after that you will be continuing in your NET and JRF examinations. No lose your time, so you use any moment of time, because time is the important jewelry of our life. So you punctualize and prepare care on your syllabus, pure care on your syllabus. In these days, this is the pandemic time, so you precautions, you should precautions from COVID-19 and follow advisory which is given by state and central government. Okay, thank you so much.